This is video on kinematics of particle. This is the third video. We are looking at straight line motion and we are going to take cases where data is given in graphical form. Now there is one more video for this case, that is data given in graphical form. You may also want to look at it. Alright. Now here in this video we are going to look at three rules. First rule is area under velocity time graph is distance covered. Second rule is area under acceleration time graph is change in velocity. And third rule is moment of area of acceleration time graph about a point is distance covered till that point. Now you will understand these rules better once we look at the problems. So the first problem. It says the VT graph of motion of a train as it moves from station A to station B is shown. Find the distance between the stations. In this case, we use this rule. Area under VT graph is distance covered. So all we have to do is really find area under this graph. See here, there are two triangles. So 40 into 30 by 2 and here 40 into 30 by 2 and here is a rectangle 40 into 60. And you have your distance covered. Look at next problem. It says for acceleration time diagram of a particle shown in figure, calculate velocity at the end of 3 seconds and distance traveled in 4 seconds. No problem. Let's do the first part. Area under AT graph is change in velocity. So velocity at the end of 3 seconds, all we have to do is we have to work out this area and this area. We have done that here. Is 2 into 1 by 2 is this area and 1 into 1 by 2 is this area. Sign is negative because this area is below x-axis. So you have velocity at the end of 3 seconds as 0.5 meter per second. Now let's use this rule. Moment of area of AT graph about a point is distance covered at that point. Our interest is at the end of 4 seconds. So we look at this total area. We take first area. Area was calculated as 1 and distance of a centroid from this point is 3. So we have moment of this area about the point of interest is 3 into 1. And similarly, moment of this area, negative area about point of interest is 1 into 1. 1 is the area and next one is the distance from 3 to 4. Sign is negative because it's below x-axis and you have distance traveled as 2 meters. See the next problem. It says particle starting from rest travels along a straight road and for 10 seconds has an acceleration as shown in figure. Find the distance traveled in 10 seconds. So we have this rule. Moment of area of AT graph about a point is distance covered till that point. So all you have to do is find moment of these two areas about this point. So first is parabola. Its area is 6 into 6 by 2. Its centroid is located at 6 by 4 from here. So 4 plus 6 by 4 from this point. So moment of this area about this point is 6 into 6 by 3 multiplied by 4 plus 6 by 4. And for this rectangle, the area is 6 into 4. And the distance is 4 by 2, that is 2. So you get total distance covered or total distance traveled in 10 seconds as 114 meter. Look at the last problem. It says two-stage rocket is fired vertically from rest with an acceleration as shown. After 15 seconds, the first stage burns out and the second stage ignites. Find the velocity and distance traveled at 15 seconds and 40 seconds. Very simple. Area under AT graph is change in velocity. So if you are talking of 15 seconds, all you have to work out is area of triangle. We use 15 into 15 by 2, 112.5 meters per second. Now, for distance traveled in 15 seconds, you have this rule out here. Moment of area of AT graph about a point is distance covered till that point. So you have to find moment of this area about this point. Is area 15 into 15 by 2 multiplied by 5. Why? 15 by 3 is 5. That is the distance of the center of this area from this point. Now if you are talking at velocity at the end of 40 seconds, you take this area and this area. This area was already worked out, 112.5, and this area is simply 25 into 20, and you get your answer out here. Now distance traveled is 40, means what you have to do, you take moment of both the areas about this point. Here it is. 25 into 20 is this area multiplied by half of 25, 12.5. And for this triangle, this is the area, and the distance of the centroid from this point is 15 by 3, 5, and this distance 25. So 96.25. So here we have applied these three rules to these four problems so that we are comfortable with finding velocities and the distances traveled if Vt and At graphs are given to us. Thank you.